Welcome to the first video for Chapter 6, which is Section 1. Chapter 6 is going to be a continuation of triangles. We're going to be learning about more relationships within triangles and between triangles. This first section has to do with ratios, proportions, and the geometric mean. So we are going to simplify ratios, solve proportions, and find the geometric mean. Simplifying ratios and solving proportions you've seen before. You did that in Algebra 1. Finding the geometric mean is going to be a little bit new. Let's start out by defining what is a ratio. So a ratio is a comparison of two quantities. So I might want to compare the number of boys to the number of girls in a class. So let's say in our class we want to compare how many boys are there to how many girls are there. Okay, so there might be 10 boys, but 12 girls. Now you want to keep a ratio in simplest terms. 10 and 12 are both divisible by 2. When I divide both by 2, I get 5 to 6. So this is my ratio of boys to girls. What this is telling me is in my class, for every 5 boys, there's going to be 6 girls. So every time you have 5 boys, you're also going to have 6 girls in the class. There are 3 ways to write ratios. So the first way you've already seen, 5 and then the colon 6. The second way is you can write 5 to 6. And then the third way is to write it as what appears to be a fraction, 5 over 6. So 5 boys over 6 girls. I am primarily going to use the first and the third way to write ratios. Okay, so looking at example number 1, it says simplify the ratio. 64 meters to 6 meters. Now in ratios, you don't need units. It's understood that you are comparing two quantities of the same unit. But I do need to simplify this 64 to 6. Now 64 and 6 are both divisible by 2. When I divide them both by 2, I get 32 to 3. This would be my simplified ratio. Now beyond simplifying ratios, we're actually going to use ratios. So let's look at example number 2. It says the measures of the angles in triangle CDE are in the extended ratio of 1 to 2 to 3. Find the measures of the angles. Okay, so first of all, we have what's called an extended ratio. An extended ratio just means you have more than 2 quantities. So in example 1, we compared 64 to 6, 2 quantities. And then before that, we compared boys to girls. Here, we're comparing 3 angles. So more than 2 quantities, this is called an extended ratio. So then we're talking about some triangles. Let's draw this triangle. So we have triangle CDE, and the angles are in the ratio 1 to 2 to 3. Now, that doesn't mean that the angles are 1 degrees, 2 degrees, and 3 degrees. It means that I had some ratio of the angles, and I simplified them. And when I simplified, I got down to 1 to 2 to 3. So really, I had some common number that I divided out of all of them. Let's call that common number x. So looking at example number 2, that common number would have been 2. I divided everything by 2. Here I need to find out what that common number is though. So I'm going to call the angles 1x, 2x, and 3x. Now I know that these sum to 180 because this is a triangle. So I'm going to have x add 2x add 3x equals 180. This gives me 6x equals 180 and x equals 30. Now if my x equals 30, this means I have one angle that's 30 degrees, one angle that's 60 degrees, and one angle that's 90 degrees. So my angles are 30 degrees, 60 degrees, 90 degrees. Now let's check our answer. So if I write this as a ratio, I get 30 to 60 to 90. If I divide all by 30, the greatest common factor, that gives me 1 to 2 to 3, which is what I started with. So again, what we found out is that we started with this ratio 30 to 60 to 90. We divided everything by some common number, which we found to be 30, and that gave us this ratio of 1 to 2 to 3. So in a problem like this, you're always going to be trying to figure out what is that common number that I divided the entire ratio by. Okay, so let's look at another example that's similar. So the acute angles of a right triangle are in the extended ratio of 1 to 4. Find the measures of the angles. Okay, so I have a right triangle. The acute angles are in the ratio of 1 to 4. Okay, so right now I would like you to pause the video and finish this one on your own, please. Okay, let's see how we did. Now we know that we have this ratio of 1 to 4. Now this is a simplified ratio. So we had to divide out some common number from these angles. The angles couldn't be 1 degree and 4 degrees. So let's call that common number that we divided out x. So my angles are 1x and 4x. Now I know that all three angles are going to add to 180. So I have 1x add 4x add 90 equals 180. This gives me 5x equals 90 and x equals 18. Now if I substitute that in, I have one angle that's 18 degrees and one angle that's 72 degrees. Now, if we write this as a ratio so that we can check our answer, we get 18 to 72. Both of those are divisible by 18 though, which gives me 1 to 4, which is what I started out with. So again, I started out with this ratio of 18 to 72. Once I divided both angles by 18, that's how I got the extended ratio of 1 to 4, or the simplified ratio of 1 to 4. So that's ratios. Now we're going to talk about proportions. So a proportion is an equation that sets two ratios equal. So this you've definitely seen before. Let's look at an example. An example would be 2 over 3 equals x over 4. Now I have one ratio here and another ratio here. Remember that 2 over 3, that's the same as writing 2 to 3. And then I have these two ratios set equal, so this would be a proportion. Now in this case, we'd be solving for x. Now the way that you solve a proportion is using what's called the cross products property. So in your past class, you probably heard it called cross multiplying. The correct term is the cross products property, so that's what I'm going to expect you to use. So let's flip to the next page so that we can look at some examples. Okay, so solve the following proportions. I'm going to do the first one with you. You are going to use the cross products property. So I get 5 times x equals 2 times 8. So this is 5x equals 16. So x equals 16 over 5. Right now, you pause the video and try the next two, please. Okay, let's see how we did. You should have used the cross products property to multiply. So you get 14 multiplied by y minus 3 equals 7 times y. So this is 14y minus 42 equals 7y. If I subtract 14y from both sides, I get negative 42 equals negative 7y. Dividing both sides by negative 7, I get y equals 6. And then for the last one, x times x is x squared, and then I have 5 times x plus 10. So this gives me x squared equals 5x plus 50. If I subtract 5x and I subtract 50, I get x squared minus 5x minus 50 equals 0. Now, this is a review from Algebra 1, so you might not remember how to solve this. Anytime that you have a quadratic, you're going to try to factor it. So in this case, I'm going to have x times x. Now I need to know two numbers that multiply to negative 50 and add to be negative 5. So two numbers that multiply to negative 50 and add to be negative 5. That's going to be negative 10 and positive 5. Now I set these two parts equal to 0. So I get x minus 10 equals 0 and x plus 5 equals 0. This gives me x equals 10 and x equals negative 5. So in this case, you have two different answers. Now, if you don't remember that, that's okay, but that is a review from Algebra 1. So theoretically, you should know how to solve a proportion like this. So that's just solving straightforward proportions. We're also going to be solving proportions in word problems. So let's look at this next word problem, the mark and recapture problem. It says the park rangers want to estimate the deer population in a forest close to your house. They capture 50 deer and tag them all. They let the deer back into the forest. 2 weeks later, they capture 25 deer. 10 of these deer are tagged. What would you estimate the deer population of the forest to be? Okay, so let's look at the important information. It says they capture 50 deer and they tag them all. Then, 2 weeks later, they capture 25 deer, 10 of which are tagged. Okay, so we have two time periods here. We have what they originally did, and then we have the 2 weeks later. 2 weeks later, I captured 25 deer total, and out of those 25, 10 were tagged. So that's my first proportion, or my first ratio. After 2 weeks, out of 25 total deer, 10 are tagged. Originally, I had 50 deer that were all tagged. That goes in the numerator because those are tagged. So 50 goes here. I want to know originally the total number of deer. So I ended up setting a proportion. Now you're going to have to use the cross products property. Once we use the cross products property, 10 times x is 10x. 50 multiplied by 25 is 1,250. If I divide by 10, I get 125. So we would estimate the deer population to be around 125 deer. Now this method is actually used. The mark and recapture method is actually used. So if you remind me in class, I'm going to show you a quick video about how the mark and recapture method is used in real life. But moving on, we're going to go on to the geometric mean. So the geometric mean of two numbers a and b is the number x that satisfies this proportion. X goes on the diagonal, and then a and b go diagonal from each other. So let's do an example. It says find the geometric mean of 12 and 16. So the way that this is going to work is x and x are going to go diagonal, and then 12 and 16 are going to go diagonal. Now we're going to solve this using the cross products property. So x multiplied by x is x squared. You're always going to get x squared. And then 12 times 16 is 192. Now I'm going to take the square root, and I'm going to have to simplify the square root of 192. So this is going to be 4 times 48. 48 is 4 times 12. 4 is 2 times 2. This 12 is 4 times 3. And this 4 is 2 times 2. And this 4 is also 2 times 2. So remember, when simplifying a radical, you look for all those pairs and then you look for the numbers left over. Now from each of these pairs, a 2 is going to come out. So I have 1, 2 from the first pair, 1, 2 from the second pair, and 1, 2 from the third pair. The other 2 in each pair we just forget about. That 3 that's left over goes under the root. Now 2 times 2 times 2 is 8, so we get 8 root 3. So the geometric mean of 12 and 16 is 8 root 3. So let's do one more example, and then you guys are going to do one. Find the geometric mean of 12 and 27. Okay, so again, we're going to set up a proportion. X and x go diagonal, and then 12 and 27 go diagonal. Now, using the cross products property, x times x is x squared, and 12 times 27 is 324. Okay, so now I'm going to have to break down that 324. So 324 is 4 times 81. 4 is 2 times 2, so here's a pair. 81 is 9 times 9. Don't keep going, that's already a pair. Okay, so one of the 2's comes out and one of the 9's comes out. 2 times 9 is 18. I don't have anything left over. So the geometric mean is just 18. Right now, I would like you to pause the video and try this last one on your own, please. Find the geometric mean of 18 and 54. Okay, let's see how we did. You should have set up a proportion. You have x, and then you have 18 and 54. After using the cross products property, you get x squared equals 972, and then you should have broken down that 972. It's okay if you use a calculator because that's such a big number. After you simplify, you should have gotten 18 root 3. So the geometric mean of 18 and 54 is 18 root 3. If you didn't get that, you did something wrong. When you come to class tomorrow, I'm going to be checking to make sure that you have this problem completed. If you got this right, move on. If you got it wrong, make sure you go back and fix your answer, please. Okay, so we have one last example to do. Today's video, we talked about simplifying ratios, solving proportions, and finding the geometric mean. You are to simplify this ratio right here. The first thing that I will tell you is that the numerator and denominator have to be in the same units. So right now I have inches to feet. So my suggestion would be change that numerator to inches and then simplify your proportion. When you come to class tomorrow, I'm going to be making sure that you have this problem done. Good luck!